Hi there, it's Mrs. Scarple, and we are starting Chapter 5, Systems of Linear Equations, specifically solving systems of linear equations. So what specifically is a system of linear equations? It's a set of two or more linear equations in the same variables. So you might be asking, what exactly does that mean, or what does that look like? Well, here's an example of one linear equation in standard form, 3x plus 4y equals 2. And here's another example of a linear equation in slope-intercept form, y equals x minus 3. That would be considered a system of linear equations. Typically, if you only have two variables, you're only going to have two equations. If we were to have three different variables, we would have three equations. You don't need to worry about having three equations in this class. We will only focus on having two equations. Now, what does a system, or what does a solution look like to a system? It's an ordered pair. So I'm just going to make a note that this is an example of what a system looks like. An example of a solution is an ordered pair, so a point. So we could have the point negative 3, 4. This is not necessarily the solution to the system up above because I've not solved it. But that's an example of what the solution would look like. It's an ordered pair. There's an x value and there's a y value. Now we can check if a point is a solution to a system of linear equations, and if it is, that point has to be true for both equations. So we need to check it in each equation. So every point has an x value and a y value. So 5 in this first example is x, and 1 in the first example is y. So I would check, does 5 plus 1 equals 6? That's true. So far, the 0.51 would be a solution. So let's check in the next equation. Does 2 times 5 subtract 1 equal 9? Well, that ends up being 10 minus 1 equal 9. That is also true. Therefore, the 0.51 is a solution. Let's check the other point. We have negative 1 for x, and we have negative 5 for y. And both of these equations are in slope-intercept form. So y is negative 5. Will that equal 3 times negative 1 subtract 2? Well, 3 times negative 1 is negative 3. Subtract 2. That does equal negative 5. So that is true. Does negative 5 equal a negative 1 plus 2? Well, a negative 1 is a positive 1 plus 2. That is false. 1 plus 2 is 3, not negative 5. Since both of these statements are not true, we would say that negative 1, negative 5 is not a solution. So that is how we can check to see if a point is a solution. And this is very important as we go through this chapter. If you're wondering if your answer is a valid answer, just take it and plug it back into the system. If it works in both equations, then it is a solution. We're going to be solving our systems in this particular section by graphing. Now, when it's in standard form, like these two equations are, we could rewrite the equation in slope-intercept form, y equals mx plus b, or we could find the x and y intercepts. I am going to go ahead and just rewrite the equation in slope-intercept form. So with the first equation, I'm going to subtract x from each side so that we have y equals negative x plus 6. And remember, when you have a negative in front of your x, that's like saying negative 1x. So the slope is going to be negative 1, and the y-intercept is going to be 6. So I would plot a point at 6, and my slope is negative 1, so that's down 1 and right 1. Down 1 and right 1. Or I could do the opposite and go up 1 and left 1. Up 1 and left 1. And I can graph a line through. And anytime you graph a line, you want to make sure to put arrows on the end as well, because lines go on forever. Unless you're given a specific domain. For the second equation, instead of subtracting the 2x, I'm going to go ahead and add the y to make the y positive. So I'll have 2x equals 9 plus y, and then subtract the 9. So we have 2x subtract 9 equals y. That gives us a slope of 2 and a y-intercept of negative 9. So I plot a point at negative 9 for my y-intercept, and for my slope, that's up 2 and right 1. Up 2 and right 1. I'm going to keep doing this. And you see that it intersects my first line. Graph my line. And put some arrows on it. And now I'm going to identify the solution. The solution is going to be the point where the two lines intersect. In this case, the solution is at 5, 1. So if we check, 5 plus 1 is 6. And in the second equation, 2 times 5 is 10, subtract 1 is 9. That works. So our solution is 5, 1. Here's another example. Our equations are already in slope-intercept form. So we can go ahead and start graphing, start identifying our points. So for the first equation, we have a slope of negative 1, and we have a y-intercept of 5. So plot a point at 5, that's down 1, right 1. Or we could be going up 1, left 1. Graph a line through. I'm going to change the color so it matches the points. For the second equation, our slope is 2, Our y-intercept is -1. Plot our point at -1, up 2, right 1, up 2, right 1. Your slopes won't always be -1 and +2. I know we've had 2 examples now where that has been the case. That will not always be the case. And we look for that point of intersection, the point where the 2 lines intersect, and it's at x is 2, y is 3. So let's check. When I put 2 in for x, that's -2 plus 5. Y should be 3, and that is the y value of our point. In the second equation, 2 times 2 is 4, subtract 1. That also is 3 for our y value. So we did graph this correctly.